Hello, I'm Professor Michael Tonks, and today I'm going to talk to you about the computational material science research that's taking place in the Material Science and Engineering Department here at the University of Florida. So computational material science encompasses the set of computational tools that are used to investigate the material behavior, what happens and why it happens. And there's various methods that span a large set of length scales, ranging from ab initio methods that are using first principles driven simulations to look at the behavior of just a few atoms. And then molecular dynamics, where we're now taking advantage of empirical potentials to do millions of atoms. And then up to the microscale, where we can use methods like the phase shift method and micromechanics to be looking at the coevolution of the microstructure and the properties. And then finally, we can take all of that information together and use it to develop materials models that can be used at the macro scale to help us predict and optimize the performance of real devices. Now, there's three of us here at the University of Florida doing this sort of research. First off is Professor Richard Hennig, who's doing these methods at the very small length scale with ab initio methods. He also takes advantage of advanced data science tools like machine learning to do things like structure predictions and looking at a range of different applications. Dr. Simon Philpott also uses ab initio methods. He also uses molecular dynamics and looks at materials in extreme conditions, things like nuclear materials and nuclear waste, and also looking at just basic simulation methods. And then myself, Professor Michael Tonks, I do work at the mesoscale. We are looking at, I also develop macroscale models for macroscale codes. And we look also at the behavior of materials in extreme conditions and nuclear materials, and then also looking at the development of numerical methods. And then all three of us take advantage of a powerful tool here, which is the HyperGator supercomputing capability, where we now have the third largest computer at any educational institution in the world. Well, thank you for your time.